Homebuyers aren't scrolling through pages of blue links. They ask AI systems for a recommendation, and the AI provides a single, definitive answer. If you aren't that answer, your website never loads. To get recommended, an agent has to provide the AI with structured, schema-validated facts, things like verified credentials and real-time listing data. These are the deterministic signals that LLMs scan to ensure they are providing accurate information without hallucinating. Most real estate software is built on legacy SaaS platforms designed for human browsing, not for feeding machines. These systems often carry heavy database overhead that makes it difficult to serve the clean, instant data structures that modern AI systems use to verify an entity. This creates a technical conflict. When your visibility depends on how quickly and accurately an AI can read your data, the underlying architecture of your platform determines whether you are the recommendation or simply part of the noise. Agentic Tools was built to resolve this conflict. The engineering goal was to deliver a full multi-tenant CRM interface within an 18-kilobyte payload, specifically designed to load instantly on mobile devices. This is the Aura interface. It uses an Obsidian Void background with translucent glass-morphic data cards. The system is designed to transition between this mobile view and a desktop layout without any change in the core codebase. The challenge is that the user data lives inside Go High Level, a legacy CRM monolith. Like most enterprise platforms, it serves heavy, unoptimized responses that are difficult to process quickly on a mobile front end. Connecting a lightweight interface directly to this type of third-party API creates latency. The front end becomes a prisoner to the monolith's data structure, inheriting the same bloat that slows down the user experience. To solve this, we used a SaaS wrapper strategy. This architecture allows us to pull the raw data we need while stripping away the structural baggage of the legacy system before it ever reaches the user's screen. Reaching that 18-kilobyte target required a complete decoupling of the front end. We moved routing, authentication, and state management out of the monolith and into a custom-built edge layer. The application runs on Astro 6 and Preact, using Vercel's server-side rendering to handle taint generation as close to the user as possible. When a request hits the edge node, middleware scans the incoming hostname, identifying the tenant and injecting design tokens like the -Aura void background color directly into the HTML. This single codebase serves multiple white-labeled domains at once, applying styling dynamically without duplicating components. To prevent users from seeing stale versions of the site after an update, we use a strict cache control no-store header. This ensures that mobile apps always fetch the most recent code bundle from the server. Feature access is controlled by a centralized module registry. This registry dictates which tools are visible to which tenant, serving as the definitive map for what the server needs to compile. By handling tenant resolution and feature gating at the edge, the server only ships the code required for that specific session. This is how we maintain the 18-kilobyte payload even as the platform scales. Standard marketplace OAuth is often unreliable for multi-tenant systems. It struggles to maintain distinct sessions when an agent moves between different sub-accounts, which leads to credential drift and login failures. To fix this, we bypassed OAuth entirely and built a custom session bridge using injected JavaScript. An injected script waits for the CRM's post-login state to intercept the authentication token. It captures the Firebase JWT, extracts the location ID, and posts the payload to an Astro API endpoint. Our backend then verifies authenticity using Google's RS-256 public keys. Once verified, the system performs a database lookup to ensure the user's ID is correctly mapped to that specific location ID. If the user is provisioned, the system generates a Supabase magic link. This link automatically redirects the user into the custom wrapper, establishing a clean session without any additional input. This bridge replaces the unpredictable nature of OAuth refreshes with a deterministic identity proof. It ensures the user is always logged into the correct subaccount with no risk of session leakage. By owning the identity bridge, we can maintain the legacy system's login security while removing its architectural constraints. A client-side application communicating directly with a third-party API is a security risk. It's too easy for a user to alter requests to try and access data from other accounts. To prevent this, every request is routed through a Supabase edge function that acts as a server-side traffic gateway. The security of this gateway relies on a composite primary key structure. In our database, we pair a single user ID with a specific location ID to create a unique, isolated record. This structure allows an agent to belong to multiple sub-accounts without their data overlapping. Each mapping is its own record, which keeps the session data for different locations completely separate. When an API call is made, the proxy verifies the user session, enforcing the correct location header on the outbound request to the CRM. Moving location scoping to the edge ensures that even a compromised client cannot request data outside its authorized sub-account. Most CRM systems use simple, linear pipeline stages to track deals, but real estate transactions are nonlinear. They involve complex milestones like appraisals and inspections that don't fit into a standard sales funnel. To support this complexity, we decoupled the state from the legacy system. We use the CRM as a data store, but we don't let its pipeline logic dictate how we manage transactions. Instead of relying on CRM stages, we materialize our own journey milestones in our database. This allows us to create branching workflows and specific task lists that exist independently of the third-party system. This setup includes a do rule engine. When an agent enters a contract date, the system automatically calculates the deadlines for every downstream milestone. The front end reads these local rows to power the next action bar. This bar scans all active deals and surfaces the most urgent tasks in one place, something the original CRM cannot do. We use optimistic UI mutations for things like Kanban moves. This means the interface updates instantly for the user, while the actual API call to the CRM happens in the background. Because these milestones are materialized locally, agents can update templates or deal structures without worrying about rewriting the history of their existing transactions. By extracting the state and materializing it locally, we gain the freedom to build a specialized transaction OS on top of a general-purpose CRM. The purpose of this entire architecture, the proxy layering, the auth bridge, and the decoupled state, is to serve the new search environment. With a clean, decoupled backend, the system can generate precise JSON LD structured data. This data is injected directly into search interfaces, providing crawlers with the raw facts they need, without the overhead of rendering a full page. This provides the deterministic signals that AI systems look for. It allows LLMs to recommend an agent based on verified data, giving you a level of visibility that legacy platforms can't provide. If you want to rank in an AI-driven search, you cannot let the rigid data structures of a legacy monolith dictate the shape of your front end. To build for this era, you have to own the identity bridge, own the proxy layer, and isolate your architecture from the monolith. This is how you build a platform that doesn't just store data, but actively drives recommendations.